Hi viewers, welcome to the video of the session. Electroactive polymers, PANI, polyaniline. I'm Dr. S. Rekha, Associate Professor, RMK Engineering College, Chennai. Let us go in deep of the topic PANI, how it acts as an electroactive polymer, the best conducting polymers. See, polyaniline PANI belongs to a semi-flexible rod polymer family. So it is produced as a bulk powder and can be casted with film or as a fiber. It can be formed in the form of sheets, okay, thin sheets, film, or the fibers. These polymers are polymerized by using aniline in the presence of an oxidant like ammonium persulfate in an acidic medium. So preparation or the synthesis is done in the presence of an oxidative material. Okay. On polymerization, polymer will exist in the three forms. You can see here in the figure, right? Basically, when it polymerizes, it forms leucomeraldin, okay, which is fully reduced state where we have NH bond, okay. Then we have emeraldine where this NH hydrogen is removed in the form of water. Okay, so this is half oxidized or half reduced state. Then we have prenygranulin, which is completely oxidized state where we don't find any NH bond at all. Hydrogen is removed completely. A very interesting part is in all the three state, it has a difference in color. Leucoemeraldine is colorless. Okay, emeraldine is green or blue color and prenygranulin is blue or violet color. So this property can also be used in the chromogenic material as sensor particles, right? Let us see the chemistry behind the synthesis. N-aniline is taken and oxidized in the presence of acid. So it produces polyaniline and byproduct as water. As the reaction proceeds, initially I get leucoemeraldine. You can see here all N is having the hydrogen. Okay, base is this polyaniline. And now if I further continue the oxidation, it turns out to be emeraldine where this hydrogen is removed as water molecule. Okay, oxygen from the oxidant is taken and hydrogen is removed as water molecule. So emeraldine is half oxidized or half reduced. Okay, it has few NH and many hydrogen has been removed. If I further continue the oxidation here, you can see prenygranulin where there is no hydrogen at all in the nitrogen molecule. So all the hydrogen has been removed, fully oxidized state. All waters have been removed from this polyaniline. Hydrogen atom is completely removed. Out of this, emeraldine, which is half oxidized and half reduced, act as a conducting polymer. This is the one which undergoes conduction. Let us see the properties of emeraldine. Okay, is regarded as the most useful form of polyaniline. Emeraldine is most stable with a conductivity in the range of 10 Siemens per centimeter, while the salt form of this has a conductivity of 30 Siemens per centimeter. So since salt is having the higher conductance, so this emeraldine is converted into the salt form. Okay, that is called doping. It has high stability at room temperature. On doping with acid, it forms emeraldine salt. Okay, on doping only, it gives you 30 Siemens per centimeter. Emeraldine forms a polyaniline form of polyaniline is highly electrically conducting in nature. So the other two, leucoemeraldine and perigranil, are poor conductors of polyaniline. Okay, here we have the structure of the emeraldine. So half oxidized and half reduced state. Few NH bond is there and many N triple bond is observed. Doping a polymer can make it as a p-type or n-types respectively. Okay, here PANI is converted into p-type doping by oxidative doping, where chlorine is added to the polyleucomeraldin so that it undergoes doping and forms this salt form. Okay, salt form is highly conductive in nature because of the ionic property, right? And here we have emeraldine, which undergoes acidic doping and forms this polyemeraldine salt. Okay, and again, which has a higher conductivity. So doping, here we get p-type doping with acidic or oxidative reaction. As we know, the three forms are of different color. Okay, leucoemeraldine is colorless, emeraldine is blue or green color, perigranulin is violet in color. So change in color can be, this property can be used for in a device as a sensor, okay, or electrochromic devices. They are environmentally stable and inert. They are optically active. Its electrical conductivity lies between copper and silver, so it almost behaves like a noble metal. Good catalytic character with photoactivity. Molecular self-assembly often forms supermolecular nanofibers. Lightweight and flexible material can be utilized in varied applications. Applications. So as I said, it's a versatile conducting polymer which finds varied applications. So it is find application due to color change in sensors, transistors, microchips. It is used as an intelligent packing material to identify the spoiled food in the tinned material, right? Packed food. Anti-static film, paints and coatings, conductive fabrics, electromagnetic shielding, conventional lead-acid battery, electronic barcode, stamps, OLED display, electrochromic smart window. This I'll be dealing in detail in the forthcoming videos. Electrochromic smart window in the chromogenic material. So you can observe that and understand it better. It is used in printed circuit board for corrosion protection. So it finds varied applications. Thank you, students. Hope so you understood better about conducting polymer, especially PANI. Thank you.